just not, again, focus shifting, right? That's not going to really be a thing anymore, and that's going to be great. Not only that, all these parameters that we want to get access to based on the data, we're going to get access to that by just going into the game, playing with something like a weapon, and by picking up that weapon, now that's going to, be inherited by the character. So it means that we're going to be able to attach all these different sounds to that gun based on what the player is doing. And I don't know, it's going to make so many of these things possible, and it just wasn't before.
Yeah, what we're trying to do is make so much data available to you where you need it and in an intuitive way. And what that means is that, when you, as you say, if you spawn a weapon in the game, it immediately becomes visible in the Claudius tool. And if you perform an action on that weapon, such as firing it or reloading it, those actions immediately become available and visible in the Claudius tool and available for you to implement. And what that means is that we're putting the implementation right alongside it happening in the game. Claudius uses a reactive programming model. And what that means is that as the data comes in, the visual side of what you see updates live, and it updates immediately. And it also has some sense of what's relevant, because if you're running an actor around, then the most recent events received by the game or sent by the game would be the movements of his limbs, the footsteps, that kind of thing. And you get to see those things immediately in the tool. And you can even filter by time. So you can look at things, you can like clear out the view, perform an action, and now that's the only thing you can see. So you get really quick, easy access to all the data you need. And all of this tech, I think, just puts us in a great position to continue to support the ever-increasing demands of CIG's games.
I also think that the designers are going to be quite empowered by the amount of time that they're going to have to focus on the creative aspects because of this tool.
Yeah, that's the whole philosophy of this design, is to empower the sound designers to be sound designers.
Yeah.
So let's take a look at a practical example, marking up a weapon in Claudius. As we've mentioned, all the events and parameters that arrive in the Claudius interface are things that have happened in the game. The game is just describing what's happened, and it doesn't have any preconceptions about what the audio system should do. It simply provides data. So, for example, the weapon fired, it now has 5 rounds in the magazine. The weapon fired again, it now has 4 rounds in the magazine. And lots of other information as well, such as, the weapon fired and there was this much atmospheric pressure around it, or it was out in space and there was no pressure. All these sort of contextual things become available. And the decisions about what that data actually means to you guys all completely come down to you. So all we do is as programmers, is we provide as much data as we possibly can in a place where you can use it.
What amazes me about this tool is it's going to just be as simple as, hooking up a couple nodes and seeing the results in the editor. Not only that, all this complex logic that we have, we're going to have access to all these parameters super easily. So the idea of, let's say, having a different reload sound based on the amount of ammunition in the mag it's going to be, rather simple to implement.
Yeah, absolutely. What we've done here is we've gathered all the data that may or may not be relevant to you, and we don't mind whether it is or not. We deal with all the code side and the efficiencies of that. And you guys get access to any data that you may or may not be interested in. So you could do like crazy things if you wanted. You could make it so that the reload sounds different if there are, like you say, if there are different number of rounds in the mag, but you might want to make the reload sound different if the character's wearing armor or not.
Yeah.
I mean, that makes no sense, but all this data becomes available to you, and it's totally up to you guys what you do with it. So we're opening up lots of possibilities.
I think that comes back to empowering the sound designers again. I think all this freedom creatively it's going to be great.
Yeah, absolutely. And I think that sort of giving you that creative freedom, I think, is going to be amazing to see what comes out of that. Because, for example, we can have something like a parameter that says whether it's nighttime or not. And if you wanted, you could change the whole aesthetic of the game, change all the sounds based on it being nighttime.
Yeah.
And that would require no input from the code team because we've given you the data you need. So let's dig down a little into some specific features of Claudius and look at budgeting and aggregation. In this video, we have a set of audio trigger spots that are all playing the same sound. We haven't applied any sort of budgeting to them, so they all play, they're all taking up resources, and we can hear them all, so the mix can be a little bit sort of muddied by just how many of them are playing. I want to show here just how simple it is to deal with that and to reduce the budget for the sounds that they're playing.
Nice
So
choice.
here we go to the audio source settings, and we're going to add a new category, which is how we budget, and we're going to reduce the number of sounds in that category that can play at any one time. As I said before, this all updates live, so every change we make now is going to be reflected in the game. And when we spin back to the game view now in the editor, you'll see that because we set the budget to 5,
Hi.
only 5 of those
Welcome.
sounds are now playing, represented by sort of lighter green. We can go back and we can change the budget, and again, that will drop it a little bit more. You can see now only the closest 3 to the camera are currently playing, and then we'll just whiz the budget back up so you can see they all come back again when you do that. Now, that's the budgeting feature, and that's one tool to sort of reduce the amount of resources we use. But what we also do is allow you to deal with what happens when all those sounds that are not allowed to play because of the budget are prevented from playing. So what we do is we have a system called an aggregation
Smart
system.
buy.
And every single one of those sounds that hasn't been allowed to play can contribute to a further sound that attempts to represent that crowd of sounds that were not played. So here we're going to do a really simple example. We're going to hook up a sort of more musical tone to this aggregate. And what this aggregate will do is it will represent all of those sounds that aren't playing. Now, we offer lots of parameters to this aggregation system, but the aggregate is aware of how many sounds it represents, it's aware of the position, it's aware of the spread of them. So lots of information is made available to the sound designers so that they can represent this mass of sounds with just a single audio source. Okay, so now we can see that there's a further light green blob in amongst all the dark green. And
Good
what that
purchase.
is that's the aggregated sound. So that will move to the center
Nice.
of wherever the crowd of non-playing sounds is. And as you can see, it kind of skips around in this video, but we have smoothing options so that it doesn't sort of jump around and become jarring. It just moves around as quickly or slowly as you want it to with the crowd of sounds that it's attempting to represent. And what this means for us is that it makes it a lot easier to sort of clean up the mix if you've got a lot of things that have been added to a level. They've been added by a non-audio person, and with maybe not so much understanding of the consequence of that, it gives us really easy ways of dealing with that. You can see here, if we increase the budget, the aggregated sound moves further away. And then if we completely reduce the budget to nothing, then you end up with just a fixed aggregated sound right in the middle of all the sounds that are playing. All the sounds that are not playing. Now, this is a really simple example. None of these sounds are moving, but if they were moving, then that blob would move appropriately to the position where all those sounds are.
I think what this tech has showed us is for ambience work specifically, the designers are going to have quite a lot of creative freedom to kind of go wild and rely on this technology to help us clean up not only the mix, but the voice count and the channel counts. It's also a good way for us to create accurate background dialogue, or as we call it, walla, for bespoke locations, and I think it's going to bring a lot more life to locations.
Absolutely. But also, aggregate logic doesn't have to be used for those purposes. It can be used for more abstract purposes as well. So we can use the logic system within the audio system to understand how many of a certain thing exist in the game. So if, say, every tree tells the audio system that it exists, we don't necessarily want to play a sound on all those trees, maybe unless it's windy, which is a decision we can make if we want. But we can track count, so we can track how many of a certain object type there are, and we can use that information to inform something like the mix. So you can have a mix that's maybe specific to forests. You want something to sound like a forest, you want to bring in some ambience that makes it sound like a forest, and that can all be driven by this set of data that we're not actually playing sounds directly on, we're just using it to inform the mix. Another feature that we have in Claudius is logic inheritance. And what that allows us to do is to implement a set of audio logic on a certain audio node and then inherit it on child nodes of that node so that we can override it, repurpose it, or make it just basically do the same thing as the parent node does. Now, that's quite an abstract thing to say, I know, but what it means is that we can use a single set of events and parameters to express audio across multiple nodes in the game.
I think this comes back to the example that we used before about, a weapon reloading. And so by overriding that logic, we're going to be able to place audio events on specific parts of the weapon and make them perform based on what the character is doing. seems like a really powerful tool to have.
Yeah, absolutely. And again, it's all about putting all the power in your hands.
Yeah.
You know, for example, you might have something like a character who jumps and lands, and that jump event can be expressed on any bone of his body. So if he's wearing a watch, you can make it jingle.
Yeah.
You know, if he's got a cracky knee, you can make it crack when he lands or something. And you know, all these different things can be done, and they're all available to you by default.
And quite easy to implement as well, as we're seeing.
Another thing we have in Claudius is a set of systemic parameters, and what they are is a set of parameters that are available by default to any audio node in the game. Things such as atmospheric pressure, velocity, acceleration. So for example, you can do something like take the atmospheric pressure and the acceleration of an object, and you can use that to express some wind noise. And that's something that previously would have required code support, but you guys can just dive in and do it on literally anything. You can add an SIG audio component to something that the audio system's never seen before, and you can start expressing the audio on these things in this way.
Claudius, I think, rationalizes the whole process of being a sound designer on this project. All that relevant information is going to be in one place, and it's going to be quite digestible, especially for people just getting started.
Yeah, absolutely. We want the sound design process to be as organic as possible, and we want you guys to have the freedom to just express yourselves, and that's the point of getting all this data to you by default. So let's take a look at an example of something you can do using SIG Audio and Claudius without any code support. Here, we're adding a SIG Audio component to an entity type that's never had one on it before. It's a really simple thing to do. We just drop the component in DataForge, and then we can jump over to the editor and we can spawn one of these things. And I'm going to use the example of a plushie here. And what we're going to do is we're going to use some of these systemic parameters and events that come for free without any extra code support, and we're going to use them to express. It's a bit of a silly example. We're going to use them to express the contents of this plushie. So what looks like a cuddly toy right now is going to turn